All right, so we can also use some of the things that we've learned previously with segments and angles. The segment addition postulate is something that we learned in the previous unit. Angle addition postulate, definition of supplementary, all of those things can be applied in proofs. So in this particular proof, it's giving me one piece of information. So it's telling me that AC is equal to BD. So that is what it's telling me. So AC is equal to BD. Those are the same length. And we're going to verify that AB is equal to CD. This is what I'm trying to prove. So if it says verify or if it says prove, that's telling me what my last statement should be. So from here, what it tells me, this is my given, this is my prove. So the first step of this should be that given, which is AC equals BD, and my goal is to get AB equals CD to be my last statement. So this is what I'm working towards. So I'm going to go in and write it here, but I don't know why I can say it yet, other than it's already written on the other side. So down here, I'm just going to bring it down here and say that this is my goal. My goal is to get this as my last statement. All right, so now since we're looking at AC, and that has two little parts in it, and we're looking at BD, and we know that those together are the same, but each of those segments is made up of individual parts. So if you see a segment that's made up of smaller parts, that's a good indication that you will need the segment addition postulate. So this is not based off of that previous step, it's based off of something we've learned before. So since I see a segment that's made up of two smaller parts, I'm going to say that the whole segment, AC, is going to be the sum of its two parts. So segment AC is made up of the two parts AB and BC. I can also use it with that second segment because I noticed that the segment that they gave me, BD, is made up of two smaller parts. So BD equals BC plus CD. So notice that these two statements came on the same line. That's because they're using the same postulate. So the segment addition postulate said a segment is the sum of its parts. Now that I know that AC is equal to AB plus BC, and I know that BD is equal to BC plus CD, notice that those things came up in that first statement. So I wasn't able to do anything with the original statement until I came up with something else. So now, if AC equals BD and AC is equal to AB plus AC, I can replace that. So I'm going to take the original statement, I'm going to say if AC equals BD, then, now that I'm using these two together, so if AC equals BD and AC equals AB plus BC, I can replace AC with AB plus BC. I also know that BD is equal to BC plus CD, so I can replace anywhere I see a BD with those two things added together. So BC plus CD. So now I have substituted in those little parts. So I replaced AC with the sum of its parts, and I replaced BD with the sum of its parts. And I had to list those in my proof in order to be able to use them. So I can only use things that are listed above it. All right, now that I know this, I want to come up with a way to get to my goal. So my goal was to say that AB is equal to CD. So I noticed those goal parts. The AB is in this statement that I have now, and CD is in this statement that I have now, but both of them have a BC with it. So one thing that I can do is, since it's being added on both sides, I can subtract it from both sides. So that's called the subtraction property of equality because that's the work that I do in between there. And then after I subtracted, I get to that goal statement, which said that AB is equal to CD. So a proof is a way to use deductive reasoning to come to the conclusion that you're trying to get. So you have a goal answer that you want to get to, but you have to be able to have a logical order of steps to get there. So in geometry, there isn't ever it looks like it kind of reason. That's out the window. We have to use deductive reasoning to get from point A to point B. All right, so here's another example of a two-column proof that uses some of the previous things that we know. And we are given two things here. So these are the things that I was given. And then it says to show that A is supplementary to B. That's my goal. So I want to get to this point. I want to be able to say that angle A is supplementary to angle B. So that's how I'm going to shorten that. That's my goal. That's where I want to get to. So some things that I know, if I just think about things that I can use, I see the word supplementary, so I can use the definition of supplementary. I see some angle measures that are given to me. And I know that to use the definition of supplementary, I'm going to have to find a way to add them together. So this is where students get really frustrated with geometry because you see the numbers, you can add them together, but we have to have reasons for why we can do it. So it's really training your brain to think logically and to kind of question the things that you've learned before and to be able to prove why you can do them. So we're going to start, our first statement and our first reason should be given to us. So I'm going to start with those givens. The measure of angle A equals 70 degrees. And the measure of angle B equals 110 degrees. So that was my given. That first part of your proof should be the easy part. It should be up in the statement above. All right, so I know that my goal is going to be to add them together. But if I think about the properties that I was given, the only property that I was given was the addition property of equality. So the addition property of equality says that you have to add the same thing to both sides of an equation. So what I'm going to do is I'm going to start with one of these statements. So I'm going to start with the core of the measure of angle A equals 70. And I'm just going to put some space in between because I'm going to add something to both sides. So I have to add the same thing to both sides. And I know that what I need to do is 70 plus 110. Because I can see that from up above. And I need to say that they're supplementary. But if I'm going to add something, it has to be the same thing on both sides. So if I want to add 110 to 70, I have to add 110 to the measure of angle A. So I've added the same thing to both sides. That is the addition property of equality. Now, the only thing that you don't have to show, like in a step by itself, is arithmetic. So if you're adding numbers together. So from here, I can change like addition and subtraction to its sum or difference just using the property of substitution. So here I'm just going to go on and add those two numbers together. I had to show that I was adding 110 to both sides. And then I'm going to use substitution. So the measure of angle A plus 110 is going to equal 180 degrees. So what I did was I just added these together. This is not the addition property of equality because it did not happen on both sides. So if you are doing combining like terms or any kind of simple arithmetic, that's where you use substitution. So you do not have to show the step that says 70 plus 110 equals 180. That's the only time you get to skip showing a step, and that's because we were combining like terms. So understand that our addition property only works when it happens to both sides of the equation. If we are simply adding two numbers together, that is called substitution. It's another way that we can use it. All right, so now I still haven't gotten to where I can say that angle A is supplementary to angle B. I know that when two things are supplementary, the definition is going to be useful to me. So let's think about what the definition of supplementary says. So definitions are biconditional. I'm going to write this as a biconditional statement. So two angles are supplementary if and only if the measure of angle of one of the angles plus the measure of the other angle is equal to 180. So two angles are supplementary if and only if their sum is 180 degrees. So the two angles here, the two angles are A and angle B, are supplementary if and only if the measure of their two angles are equal to 180 degrees. So this is the next statement that I need to get. So what I can do now is I'm working towards this saying the measure of angle A plus the measure of angle B. So I want to know if there's a way that I can replace the 110 with the measure of angle B. And there is. So what I'm doing here is I'm going to take that measure of angle A that I knew. So I'm taking the measure of angle A from the part above. I'm going to copy it and paste it down here. So I'm just taking that from the part above. And I'm going to take the plus sign too. Maybe. And I'm replacing 110 with the measure of angle B because in step 1 we said that those were the same. So all I've done is I've kept everything else, but I have replaced 110 with the measure of angle B. So that's another version of substitution. So here it's substitution, but I'm using it from statement 1. So because it was listed in statement 1, I can substitute it in here. All right, now that I have that the measure of angle A plus the measure of angle B equals 180 degrees, that's familiar because that's part of this definition. So since it's part of this definition and this definition is biconditional, it says that I can use it either way. So since I know that the measure of angle A is, or A plus the measure of angle B is 180, now I can say that angle A is supplementary to angle B, which was my goal. And the reason I can say that is right here. It's this definition of supplementary. So we were able to use the definition of supplementary to prove that A is supplementary to B because we had this if-then statement. So if the measure of angle A plus the measure of angle B equals 180, then angle A is supplementary to angle B. That was the converse of this conditional statement. So that's how those conditional statements and deductive reasoning plays into our proofs that we're going to be doing this year.